Let's start off with something that I didn't put on the test that I could have.
Oh, yeah.
All right, Jeff. You go see that.
So this guy is my painting class. They really copied and pasted from this website that goes around. So they copied and pasted it and then put it in place. I love this website.
All right, guys. So let's try this out. We've done a problem like this before a few times. It has immediate use in the next chapter, chapter 8. So find the z-scores bound in the middle 90%. Go. No C shit. So maybe. And this is in a standard, normal distribution. By the way, while I'm thinking about it, well, I'll talk about it when we do this problem. There's the mistake that somebody made on the test that several people on the test kind of drove me crazy. Will looking up 0.90 on the chart in any way help you with this problem? No. What is 0.90? It's an area. So you're going to look for it, but you still wouldn't look for 0.90. Is it the right area that the chart understands?
No.
What area does the chart understand?
0.05.
It understands the area below. I want two z-scores. Let me focus on this one just because. It doesn't really matter, but it's the easier one. There's 90% in there. There must be how much on each side? 5%. So if you look up 0.05, you'll get this negative z-score part. And the other one's going to be positive that because of symmetry. It's symmetry. What do you mean? You should be getting that situation we've seen before, the little asterisk situation. What z-score are you guys getting? So what's this? I like it. Okay, so if I told you find the middle, the ones at 80%, you would look up 0.10. I mean, so now you could do the middle whatever percent that you want. Does that make sense? Say again?
How would you do 80%?
All right, so if I want, it's the same exact process. So if I want blah, 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 80%, blah, 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 blah. So that's 80% in here, so how much is going to be on this side?
10.
Yep. So look up 0.10, as close as you can get. Should get negative 1.28, I think. Is that right? Let's see if I remember. You guys doing all right? So you guys look upset. All right. Some of you guys should be upset at yourself. So this is negative 1.28, right? Is that what you guys are getting?
Yeah.
So this will be positive 1.28. So the process didn't give a shit what the percentage is. Process is the same. So if I said 70%, you would look up 0.15 because there would be 30 out there, there'd be 15 on one side. The process is the same. I like it. Okay, now, so that is a basic skill required for the next idea. And the next idea is remarkably cool. What do we normally work with in statistics? Like to get data from something, what do I normally have? A sample. Okay, I like it. And what are we normally trying to say something about? Population. Any of you guys paying any attention to politics at the moment? You guys know there's an election coming? And The only way to make sure that you can't do anything about anything is to not be involved. That's the only way you can be sure. And I'm not forcing you to do shit, but just think about it. I don't care which way you vote, you should just vote. But has anyone seen like anything about, here's a poll, 40% are going to vote for Prop 6 and 42% are going to vote against it or something? Have any of you guys seen something? So normally they'll have on the screen, Prop 6 yes, 40%, no, 42%. What's down here? I don't know if you guys ever noticed. Something like plus or minus 4%. Right? So when you look at this, does this mean that it's not going to pass? No, because what could it be? This is plus or minus, that could be 44% and that could be 38%. They're saying that they think they're off by at most 4%. That's what that means. Of course there's going to be a margin of error. So let's think about this. If I wanted to find out what does it look like, what percentage of people are going to vote yes, I would take a sample of people and I would ask them, each one, are you going to vote yes or no? And then I calculate a percentage. Are you guys with me? Is that the real percentage of all the people who are going to vote? No. So it's going to be off by something. So what we're going to learn is how the shit do you calculate that for? Why wasn't it 3? Did they just go, I'm not sure, let's say 4%, give or take? No, it comes from math. What do you think is the most immediate thing you could do to make that plus or minus 4% go down? How can you decrease that? Yes, that 4% is kind of like a measure of how uncertain you are. How could you become more certain about something? Take a larger sample. So in the math, that 4 is going to be related to the sample size somehow. In fact, you should probably have an n on the bottom because the bigger it gets, the smaller that error should get. All right. How are we feeling about this so far? I mean, does that make just everyday freaking sense at all? No. A little bit. Okay. If I'm you, I know I'm not standard person in the world, but part of you should be like, yeah, where the shit does that come from? Did you just make that shit up? Oh, I'm really not certain. Let's make it 7. No, it comes from somewhere. All right, so we got to kind of build our way up to percentages. We're going to start with means. If I wanted to get a feel for what the average age is for something, and I took a sample. So let's take a sample of 40 people in America. You could have just said Americans, Jeff. I know. And we find the sample mean age, so we're talking about ages, is, what do you got, Jeff? I don't know, 40.2. And we know, for right now, we'll know the standard deviation is 8.17. No, sure. I like it. You got to forgive me. This is not real. But I do like using real data on tests and so forth. Like the whole warming thing, the global warming thing, those are real data. I changed the standard deviations a little bit so you guys would have different numbers. But they're basically the right data. All right. So here's the cool thing. Is this the right mean? What are we trying to get a feel for? The average age in America. So I took a sample of 40. Is that going to be the actual average age in America?
No.
Could be. Could be. But what would you put all your money on, really? Is that? I would say no. 40 people to represent all of America, I'd say that age, the average age, is probably off somehow. Now, you're right. There's a chance that it's exactly right. But it's about the same chances as you winning that thing last night. So maybe somebody's not here because they did. Who knows? Somebody in San Diego got 5 out of 6, and somebody in South Carolina got all 6 right. So I'm sorry if you guys are hoping for the next one. You're like, it's only going to be 2 million. I don't want 1.6 billion or whatever's left after taxes. I love that attitude. I love it. All right. So let's look at this. So what I want to do is I want to get a feel for what the real mean is. And let's say I want to be, this is going to sound a little weird. I want to be 90% confident in my results as far as in my estimation for the real mean. The only way to be 100% confident is to say it's between 0 and 1,000 years. Then you're like, well, that was fantastic. How much money we spent on this research? So you have to pick a certain level of confidence. How confident do you want to be? So I love statistics for this fact. There's always a chance that it's wrong. But at least it tells you what that chance is. It doesn't just say it's 7. I could be wrong. No, it says that it's 7. I'm 90% sure that it's, I love that about statistics. It's very honest. People go into math thinking, show me how to win poker. And then stats goes, well, there's a good chance to win in the long run. That's the best you can do. Freaking hell. That's real life. Holy shit. If I knew how to win poker every time, I would not be standing here. I would be playing poker somewhere. Right? I would still teach poker. Okay. So here's the idea. I don't know what the real mean is. What's true about the sample means? Why did I just draw this picture? I got a little ahead of myself. Why are the sample means normally distributed?
40?
Yeah, 40, which is greater than 30. Right? 30 is that magic number to make it normal enough. If you don't know to begin with, that's what makes the sample means normal enough. And if I put 40.2 here as an estimate, that's a decent estimate for what the middle is. Here's this beautiful idea. If I want to be 90% confident, and what I'm going to do is the percentage, I should have done this earlier. Remember when it was 40% when I vote for A, and it was plus or minus 4%? So what is the range really then? Would it be 36 up to 44? So this is an interval. So I could say, I think it's somewhere between 36 and 44%. They're not going to vote for that. And I am such and so confident. So we call these things confidence intervals. That's just like, we were like, what do we call these intervals where there's a certain confidence? So if I want to be 90% confident, I want to create an interval. And I'm 90% confident that that interval catches the real mean. Now, we took a sample of 40. You might say that's not many Americans compared to 320 million or whatever. But 40 is a decent sample size, to be honest. Its average should be close to the real average, right? That's the whole idea here. So this is so beautiful. I don't fish, but I love this idea of if I cast out a net that is big enough, I'll catch 90% of the data. If I catch 90% of the data, how sure am I that it caught the real mean? So if I went out and caught 90% of the people, how sure am I that I caught a certain person? 90% sure. What's the chances I didn't? 10% chance I didn't, right? So this idea, I love this shit. So let's see how to build this. How do I get there? And look, this looks very familiar, doesn't it? Going up and down so many so that I catch 90. In fact, we already did some work for this. What was it we just did before I put this up on the board? What's the middle 90%? What were the z-scores? Those are the z-scores, right? Mm-hmm. So all we have to do then is convert those back into raw scores, into ages. Do we have what we need to be able to do that?
Yes.
Sort of. What's wrong with this?
We have the standard deviation.
That's the standard deviation for individuals. And we're talking about groups of size 40. Okay, I like it. So here's how we do this. If I take 40 point, the first thing I got to do, well, let me build this up. If I take 40.2, let me see. Let me do this without the numbers first. Do you remember this formula here?
Yes.
Okay, all right. So, do we know the mean? The mu. Do we know mu? Do we know mu? Do we know mu?
Sort of.
No, we don't. We know x bar. So I'm going to use this formula. I'm going to use this. And then I'm going to go up and down. I'm going to go up and down so many. But what happens to this again? What happens to the standard deviation? I have to change it to be the one because I took a sample. I got a sample mean. And that's what I'm using to estimate this. So that's got to change because I took a sample and I'm talking about the sample mean. That is the formula for creating a confidence interval. It's going to say, okay, my sample's a decent guess. But if I go up and down so far, then I can say I'm this confident that my interval catches the real mean. Gives you a feel for where the mean might be. So, if I plug stuff in here, 40.2, give or take, this many. And see how the plus or minus captures the up and down? It's already in there, so you don't put a negative in there. It's already in there. You just put the 1.645 in the formula. The up and down is captured. Times the old standard deviation divided by the square root of 40. This piece, that's related to the plus or minus 4%. That's how off I think I am. How off I think this is. So we call that the error, remarkably enough. That is our error. That's how far off we think we are. So this piece is called the error. Error. So normally I would calculate that first. And then you add it and subtract it from 40.2. So somebody help me out. Calculate this error piece. Or somebody might have already done that, maybe. Let me do that with you, in case there's dissension. I like it. Sure. In general, you want to round the error to at least this same decimal place, if not more, so that's fine. So I always love it. This hasn't happened in a while, but one time I did have a student ask me where the plus or minus key was on the calculator. Unfortunately, there just isn't one. You just got to do this minus this and this plus this, right? And this feels very familiar. This is Jeff. He's been getting you ready for chapter 8 forever, right? This whole give it up and down, within 1, within 2, and here we are. We're here. So I don't know, what do you get? Is that right? Is that right?
Yeah.
Thank God. Okay. It's kind of early, so you never know if my math neurons are kicking in. So it gives a feel for a couple things. It's better than just saying, yeah, I think it's 40.2. This is much more information. I mean, if it was like 16 to 80, I'd say you should probably do a little more. That's kind of, oh, jeez. But this 38 to 42, that's pretty good. That's a pretty good interval. So just by giving this interval, you get an immediate feel of how sure you are about what you got. That is the primary purpose of a confidence interval. Okay, maybe. Now, you're going to love this. And you know when I say that, you're going to hate it. Let me erase this here. That's not the end. You will always have to write a conclusion statement.
What?
You put English in my math. You put mash in my me. All right. So, I don't know why I said mash. How do I interpret this? I've been saying it a few times already, the interpretation. And here's the idea. I really want to make sure. Hopefully you guys kind of get the idea. This is beautiful. I don't know about this. Why? It's a sample mean. So I create an interval around it that I feel decent about. How decent? What was the confidence level on this one? Do you remember? 90%. So I am 90% confident. We are 90% confident that the interval 073 years to 7 years contains the true mean age. Bless you. Bless you. Of Americans. I'm sorry, I thought it was America. Good Lord, Jeff. An American or Americant? That's the conclusion. That's what this means. That's what we did. We're 90% confident. There's a 10% chance we're wrong. So we're 90% confident that our interval that we created catches the real mean. The whole idea of the fish thing, I don't like to eat fish, but I love to throw it. You know that there's a fish, a certain fish you want, and you know that it swims this far. That's the spread. So you're going to throw out a net that's a little further, and then you're so certain that you caught the fish. That's really what's going on here. What'd you do in stats today? You learned how to fish with a net? No. All right, let me follow this up immediately with something that shows you another utility of confidence intervals. Let's say we had, so this is in Merck. Let's say we go to, where do you want to go to? Give me a country. Japan. Okay, we go to Japan, and we take a sample. Say of 47 people, and we find X bar equal to, what you got, Jeff? I really don't know. All right, let's say X bar equal to 48.1. And sigma is known to be 10.17. I like that. All right, so we go to Japan and we take a sample of 47 people, randomly selected people in Japan, and we find an average age of 48.1. So I do think Japan's expected life expectancy is higher. Ours has gone down recently. Go team. Well, I mean, we had a recession, and then we have continued. I'm not going to get into the politics of it, but yes, it just has gone down. Let me just stick to the numbers, so I don't get in trouble. So can you create a 90% confidence interval for this situation? Confidence interval, I'm just going to call it CI. Okay. Do the exact same thing we just did over there. What's the z-score we're going to use for this? It's going to be the same because I want to be the same confidence, right? If I said 95% confident, let's see if this makes sense. The z-score would be bigger because if I want to be more confident, I have to catch more stuff. That makes almost too much sense. It's a little scary how much sense that makes. And some of you look at me like, no. You're going to do the same shit, right? Just with these numbers. So this is a Merck. So now for Japan, let's go.
Our fund is 50.54.
Wait, let me catch up. 48.1 plus or minus. What do you guys get for the error?
1.645.
What do you guys get for the error?
2.440.
Yeah, so let's say 2.44. I like it. So then, confidence interval for Japan looks to be 45.66, I think.
50.54.
50 point. Really. Now watch. So again, we could write a statement. Same thing. We are 90% confident that the interval 45.66 years to 50.54 years contains the true mean age of Japanese. My brain is going to say so like Japan answers. Is there a decent with that right there? Do you see how creating a confidence interval, the steps are always the same? It's just going to have different numbers thrown in for the situation. And what different numbers? The X bar is going to be different. Standard deviation is going to be different. The confidence level could be different, so that could mean my z-score is different. Now look at these two intervals. From what we've discovered, does it look like the average ages in Japan and America could be the same? No. What's the rough estimate how sure we are about that? 90% certain. Right. So that's an immediate thing that these can do, is to test a claim. If somebody said, oh, Japanese are on average the same age as Americans, and we did this study and we say there, it's different. And then they're like, 10% wrong is too big of, so then I could redo it with 95%. Right? What would change if I said a 95% confidence instead of 90% confidence? What does that immediately affect? The z-score. And why does this so desperately make sense? 90% is captured by going up and down 1.645. If I want 95%, I'm going to have to go a little further out. Which makes physical sense. I'm going to have to catch more to be more confident. Okay, maybe. Okay, so for 90%, again, that was this whole thing. And you look at 0.05. I like it. Now, real quick, do you guys have your z-score charts? Can you look on the bottom of the positive side? The bottom right. You see how it says confidence level? Look at 0.9. What's it say next to it? So, I mean, if I have one at 90, 95, or 99% confidence, that's the quick place to go get it. Does that make sense? Yeah. Okay, so now you know me, I'm going to ask you for a 96% confidence interval. And you're going to go, Joe. You're going to have to look up, what would you look up for 96? Oh, 96. Oh my God. This would be 0.02. Because it should be 4% out there, 2% on that side. Okay, so let me give you this. You know me. I've got a handout. This handout